Hello students, I am Nilanjana Sanyal, an online math tutor from India. I tutor students of the IB and the IGCSE boards from grades 9 to 12. This is my website www.nsonlinemathtutoring.com. You may visit my website to know about my tutoring services in more detail. Okay. Now today's session is on approximations using arithmetic sequence. What does this mean? We know for any arithmetic sequence, there is a common difference between the consecutive terms, right? But in many real life situations, you'll be seeing that the difference between the consecutive terms is almost the same, but not exactly the same. So in these cases, we can use an arithmetic sequence as an approximation. Okay, because the common difference is not a constant, it is not exactly the common difference. You don't have an exact common difference, but the difference is very, very little. Okay, so for all practical purposes, they may be taken as a constant. I think the best way to understand this topic is by solving few questions on this topic so that we understand, we come to know what is getting approximated. Okay, so the first question of this session is, Selena is measuring the mass of oranges on a scale. When there are 8 oranges, the total mass is 1.126 kgs. Subpart A says, find the average mass of the oranges on the scale. Fine, so we know how to find the average. Subpart A. There are 8 oranges and the total mass is 1.126. Therefore, the average mass will be divided by 8. Okay? 1.126 divided by 8. 0.14075. This is 0.14075 kgs. Or I may convert this to grams. This is 140 point. I may take up to 1 decimal place, so it will be 140.8 grams. Okay, so each orange is weighing 140.8 grams. Now you come to know what is getting approximated, the mass of the oranges. Because it is quite obvious that every single orange will be having a different mass. At least their masses will be varying, though very little, but will be varying. They will not be having identical masses. That is what we are approximating. We are assuming that all the 8 oranges are having, each is having the mass of 140.8 grams. That is the average mass. So the common difference will be equal to 0. If I just write the masses of all the 8 oranges one by one as the number of terms, the first term, the second term and all, there will be 8 terms in that arithmetic sequence, the common difference will be equal to 0. So that is what we are approximating. We are assuming that each one is having the same mass and it is equal to 140.8 grams. So this is the answer to our first subpart. The subpart B. Hence, write an arithmetic sequence for UN, the approximate total mass when n oranges have been placed. UN, you know that UN is the term, nth term. So they are forming an arithmetic sequence which is having the mass of the first orange as 140.8. This is U1. What will be U2? The total mass of the two oranges, that is 140.8 times 2. What is that equal to? 140.8 times 2. 281.6. So 281.6 will be equal to U2. What will be U3? Obviously, it will be 140.8 times 3. So 140.8 times 3 is equal to 422.4. This is U3. Therefore, what is the common difference? The common difference is again a constant. It is equal to 140.8. Okay. 140.8. It is the common difference. Assuming that each orange is having the same mass and it is equal to 140.8 grams. So we are approximating the mass of the oranges. And they are asking us to find the value of UN, the approximate total mass when n oranges are placed on the scale. So obviously that will be n times 140.8 grams. So UN is equal to n times 140.8 grams, or UN is equal to 140.8 in grams. This is our answer to the second subpart. Okay. This is N and this is grams. Don't take it as NG to be a new unit. No, grams. G stands for grams. And the value is 140.8 times n. Okay. So let us move on to the next question. An empty carton, egg carton has a mass of 32 grams. When the carton is filled with 12 eggs, the total mass is 743 grams. The empty carton's mass is 32 grams and the carton filled with 12 eggs is having a mass of 743 grams. The first subpart says that find the average mass of each egg in the carton. Again, we will be approximating the mass of each egg. Obviously, they will not be having the same mass. This is where the approximation is coming. Okay. So, answer for the subpart A. Now, 743 grams is also considering the mass of the cartons. Therefore, I have to subtract that. 743 minus 32 over 12. This will be the average mass of each egg. So, (743) minus 32 divided by 12 is equal to 59.25. 59.25 grams. Okay. I may write this as 59.3 as well. So this is almost equal to 59.3 grams. Okay. This is our answer to the first subpart. Average mass of each egg is 59.3 grams. And subpart B says, hence write an arithmetic sequence for UN, the approximate total mass when n eggs have been added to the carton. Then in that case, we have to take the mass of the carton as well. So it is subpart B. Obviously, the mass of the carton is 32 and mass of the n eggs will be assuming that each egg is having a mass of 59.3 grams, that is the approximation that we have made. So it is, and there are n eggs, so it is 59.3 times n. This will be this part is the mass of the n eggs and this part is the mass of the carton, empty carton. So taken together will be giving us the mass of the total mass containing the mass of the carton and the n eggs in grams. So this is the answer to the subpart B. And what is the answer for the subpart C? For what values of n is your model valid? Of course, the model is valid for, we have found this 59.3 grams by assuming that there are 12 eggs on the carton, in the carton. Okay, so they have given us the mass of the empty carton, that is number of eggs is equal to 0 at that time, and they have given the mass of the filled carton filled with 12 eggs. So therefore, obviously, n will be having any value between 0 to 12 because the mass of the empty carton is n equals 0, 0 number of eggs, and filled carton is n equal to 12. There are 12 eggs in it. So the n is ranging between 0 to 12, and do not get confused. Do not take this n to be equal to the term number, and do not ask me that you had said that term number starts with 1. This is not the term number, but this is the number of eggs in the carton. Okay, so the lowest value, the smallest value that n can have is 0, and the highest value, the maximum value, is equal to 12. We cannot say what will be the figure, what will be the average when 13 or 14 eggs are placed in the carton. I do not know whether there are any empty space remaining in the carton. That is not known. And even if there is some empty space for 1 or 2 or say more number of eggs, we do not know what will the masses of those eggs be and how will they change the average mass. Therefore, the possible values of n for which this model is valid is n ranges from 0 to 12. Okay. So this is our answer for the subpart C. So let us take up one more question. Kate has 34 online friends after 1 week of joining a social networking site. After 9 weeks, she has 80 online friends. Subpart A asks us to find the average number of friends Kate has made each week from week 1 to week 9. So, the answer. Subpart A. It is week 1, Kate has 34 online friends. Now we are assuming, again in this case, what are we approximating? We are approximating the number of friends made each week. Obviously, it will not be the same every week. In some week, there will be more number of online friends. In some other week, there will be lesser number of online friends. But we are assuming that Kate is making the same number of online friends every week. This is the approximation that we are doing. Okay. So let F be the number of new friends that Kate is making every week. Okay. So week 2, after week 2, how many friends will Kate be having? Online friends? It will be 34 plus F. Okay. For week 3, obviously it will be 34 plus 2F because in each week she is making F number of new friends. Therefore, this will be continuing, and after week 9, it is obviously 34 plus 8F. Okay, this is equal to 80. So, the average number of friends is F. This is the number of friends that she is making every week. That should be equal to, F is equal to 80 minus 34 over 8. Okay. So, 80 minus 34 divided by 8. 5.75. So she is making on an average 5.75 new friends every week. Okay, so this is our answer to the first subpart. And this is the subpart A part. And what is the subpart B? Find the approximate number of her online friends after n weeks, assuming that it forms an arithmetic sequence. So, in week 1 it was 34, and every week, that is the common difference for this arithmetic sequence, is 5.75. We are approximating what? We are approximating the number of new friends made each week. We are assuming it to be a constant. So it will be after n weeks. So it will be obviously 34 plus n minus 1 times the f value, that is 5.75. Okay. So this is our answer to the subpart B. 34 plus n minus 1 times 5.75. Now, what if they are asking us what will be the number of friends after 20 weeks? After 20 weeks. After 20 weeks, how many online friends will she be having? So, I'll be just substituting 20 for n, and it becomes 34 plus 20 minus 1 is 19. 19 times 5.75. What is this equal to? 34 plus 19 times 5.75 equal to 143.25. 143.25. But we cannot have decimal number of friends. So if the question is after 20 weeks, what is the number of friends that Kate is having, online friends? We will be approximating, we will be giving the answer as 143. I'm just rounding it up. Okay. I have to do that because I cannot give the answer as 143.25 friends. It does not make any sense. You may ask me, why have you kept this decimal number in the case of average? In the case of average, it is an average. It is not how many friends she is having in the first week. If they ask us what is the number of friends she is having in the second week, I will be saying 34 plus 5.75. That is 39.75. So I will be approximating it to 40, and I will be saying that she is having 40 friends after week 2. Okay. For giving the number of friends, I have to give them a natural number or a positive integer. But the average can be in decimal. Okay. So this is our answer. We have already answered the sub-part B, and this one was the additional part that I had taken up. And we have found how many friends is she having, online friends is she having after 20 weeks. Okay. So students, this brings us to the end of this topic, arithmetic sequences. And therefore, I have 2 homework questions on arithmetic sequences. Question 1 says, find the number of terms in the following arithmetic sequence. It is 3, 9, 15, dot, 525. You see, this is a case of a finite arithmetic sequence. You have to find the number of terms. They have said it is an arithmetic sequence, so it is quite obvious there will be a common difference. If they did not mention this word, if it was not mentioned in the question, you would have had to find whether there is any common difference between the term. Okay, but now you know there is a common difference and you know the formulas, you know how to find it. So coming to question number 2, insert 3 numbers between 2 and 4 so that all 5 numbers are in arithmetic sequence. And this can also be formatted in this form, that insert 3 arithmetic means the inserted numbers are also referred to as arithmetic means. If the question asks you to insert 3 arithmetic means between 2 and 4, you will be proceeding in exactly the same way. Okay. So I would like to see your answers in the comment box. Okay. So students, this brings us to the end of this session, and in our coming session, we will be starting with arithmetic series. Okay, so we'll be meeting very soon in our next video session. Thank you for watching this video till the end. Please give this video a like in case you found it useful. Please subscribe to my YouTube channel and do not forget to press the bell icon so that you get notified as soon as I publish a new video. Okay? So bye for now.